Okay, so in 2.5, what we're talking about, and we'll need to be on page 39 here in a sec, is two different systems that you can use to measure angles, one of which you're very familiar with, and one of which you're not at all until a couple minutes from now. So when we go to measure angles, we can either measure them with degrees, or you can measure them with a system called radians that you've never really heard of in much detail until now. But you might remember the first week of the year when you got your calculator, we had to change our mode from probably preset on the calculator to radians, and we had to change it to degrees to do math right. You might not even remember that. Maybe you do, maybe you don't. But degrees have been what we've been doing up till now. Starting today, it's going to be like 50-50 between degrees and radians. The physics book will always be angles in degrees. So when you're in physics, if you're doing things with sine, cosine, tangent, running programs with your ASAs and all that, you have to make sure in physics you're always in degree mode. In trig, half the time we're going to be switching out of degree mode to be in radian mode, and that's going to you're going to be switching that. So just don't lose track of where you are. If you're ever doing a physics homework and things are going at an angle and all your answers are wrong, that could be what's going wrong. You might just need to change your mode back. Degree mode, again, it only matters if you're doing sine, cosine, tangent kind of things with your calculator. But for degrees, if we're back to standard position degrees, where are we for 0? To the right, 90s, top,
Left. 270.
360. So I just read a thing in the book as I was glancing through this, and I don't know if I ever even read this before because it didn't ring a bell. Doubtful that you know why there's 360 degrees total in that. I would be pretty shocked if you knew this trivia question, because I didn't, and I do stuff with trig every year. So on 37 it says, the degree came to us by way of the ancient Egyptians, who had figured out there were approximately 360 days in a year. So they divided a circle into 360 parts, which we now call degrees. Who knew? If the Egyptians had known a little bit more about the Earth and the Sun, you would actually be working on 365-degree system, I suppose, because that's what they were after. They say a more natural unit of angular measurement is this other thing called radians. So here's how the radian scheme worked. Radians were measuring arc lengths. There was a day in the word problem section we encountered an arc length. Do you remember what arc length? What was the arc from like a little curved thing? We're trying to do arc lengths of a thing called a unit circle. Does anybody have a guess as to what a unit circle is about? The word unit has a math meaning. It's always pretty much the same meaning. The word unit means something. Like in your place values, you have a millions place, a thousands place. Sometimes one of the places is called a units place.
Oh, what was this like a couple days ago? One. Was it
One.
Okay.
So a unit circle has something to do with one. What's a general word that's used when you're measuring how big a circle is? What's probably what you're measuring it with? It's
Circumference.
could be, but it isn't that.
Radius.
The radius. A unit circle has a radius of 1. So if I draw us a unit circle, meaning this has a radius of 1, instead of being the whole way around the world is 360 degrees, what's it called when you go the whole way around the circle? The whole way around the circle is called its
That's the circumference.
circumference. So there's the place to use that. How do you figure out a circumference? We could go 2 pi r, or we could go pi times diameter, either way. How much of a pi thing would this one give us? How far is it around this?
360.
2 pi.
2 pi. Because we said that the unit circle had a radius of 1. If the radius is 1, the diameter is 2. To get around the circle is 2 pi. So 360 degrees is 2 pi radians. It's just a fact. We're going to use that fact to basically convert. Like, I could tell you that 12 inches makes 1 foot. You could use that to convert inches into feet or feet into inches. That's just a fact. Okay. 360 degrees is 2 pi radians. That's just a fact. If I wanted to make that fact a little bit mathematically simpler, can anybody simplify that fact slightly? 360 degrees makes 2 pi.
180 equals pi.
180 degrees would make 1 pi radians. And that's going to be a little bit simpler for us to probably use to do our conversions. But that's the scheme. Instead of wrapping around a circle being 360 degrees, they're imagining wrapping around a circle to be its circumference. Instead of having 2 pi. Instead of being at 90, anybody have a thought on what the 90 would make? Half of a pi. Okay. That's the kind of thing we're trying to get to. So if we look to 39, I'm just doing a few of these homework problems free of charge. On 39, it says, for problems 1 to 8, find the exact number of radians in angles with certain measures. When they say exact, what they mean is don't round stuff. Just don't. We may use our calculator to do the basic math if you have to, but don't do any kind of rounding mechanism. So, process for this, if you want to change yourself from degrees into radians, you want to multiply by pi over 180. We'll explain why this works. If you just know that's what to do, you'll survive the homework. But what did we just decide about pi and 180? That they're basically the same. If you have a fraction where the top and the bottom are the same, that fraction is really 1. When you multiply by 1, things stay the same. They just end up looking different. It's sort of like a trig version of the 7th grade name changer machine. That if I want to make this 20ths, you multiply the bottom by 5. So you have to multiply the top by 5 to make 15. When you multiply by 5/5, you really multiplied by 1, which didn't change anything other than the way it looks. That's what we're trying to do. We're trying to change the way these look, but we're not trying to change the amount of stuff we have. So if we're going from degrees to radians, we're just going to multiply by pi over 180 degrees. Like the degrees will cancel away when you do that. If you like it, this is invisibly on top of a 1. We're not going to go decimal rounding stuff, so we are not going to touch the pi. We're not going to try to turn pi into any kind of decimal because it would never end or repeat, and that's not what we're after. When they say exact values, that's sort of code for leave pi out of this. Just leave it alone. Simplify that fraction.
Pi over 3.
It'd be pi over 3. Yeah, I cracked the zeros off. 6 goes into 18 3 times pi over 3. That's what we're after. That's what you're kind of doing 1 to 8. Just multiply by pi over 180. Leave pi out of it and have a little 7th grade remember when about multiplying and simplifying fractions. Something about 1 to 8. 9, they changed the word to say find a decimal approximation, which means well, maybe 1 to 8's that exact.
You will multiply by pi.
Yeah, we are gonna multiply the pi in, because after it says find the decimal approximation, the next magic word that matters to you is the word,
Radian.
after that,
Round.
round. We are rounding. And anything that says approximation means rounding's fine. So they're gonna take 37 degrees and repeat the process. What was the process?
Times pi over 180.
Multiply by pi over 180. Basically, it cancels the degrees away to bring us into radian town. Just use your calculator and punch it in. 37 times the pi button. The pi button is like over toward the right edge, middle somewhere. It's like up around the 9-ish area. I don't know exactly where the key is,
Looks like
but
it is.
it's with the power key. So take 37 times the pi button and divide by 180. Punch it,
0.65.
0.65, I'll take your word for it. Question about that? Okay, then 15, they changed the game. Instead of giving you the degrees and wanting the radians, they decide to give you
Radian.
radians, and they want
The degree.
the degrees. So let's think of a strategy here. If we want to go from radians to degrees,
Divide by pi over 180.
we could divide by pi over 180. I would take that as an acceptable, correct answer, but you can do a better answer than divide pi over 180. Think about what that would mean to divide pi over 180.
Multiply 180 over pi.
Yeah, because when you divide fractions, they flip. So, although it's correct to say we would divide instead of multiply because we're going backwards, I'm going to do this also in terms of multiply 180 over pi. Alternative plan, what did we just say that pi is the same as?
180.
180. So if you see a pi, a simpler plan even than that is to just replace the pi with
180.
180. So on 15, it says find the exact number, which means we are not going to multiply pi in or round in any way. Find the exact number of this. I see a pi. I would just replace the pi with
180.
180 and do the math in my mind or on my calculator if I had to. It is 60. If you didn't like that trick and you went ahead and multiplied by 180 over pi, you'd end up canceling the pi's, still get 60. On this, we can't just replace the pi with 180 because there's no pi visible. Okay, so I'm looking at 25 now. 25, the directions change. It says find the approximate number. And approximate means
Round.
we are going to round. So if we don't see a pi, we can't very well replace the pi with the 180. We're stuck with this multiply by 180 over pi. So grab the calculator, 0.34 times 180, divide by pi, bunch of.
19.48. 48. I'm sorry.
48. That works for me. They say to do degrees and minutes. I'm going to say I don't care. Let's just go decimals. If we did want to make this decimal part minutes, does anybody know how to do that?
60 divided by 48. Or 48 divided by 60.
No. Right idea, wrong direction. If I told you 19 degrees and 24 minutes, we can make that 19.4 if you did this, divide 60. We've done that a lot. We're going the other way.
Multiply.
We'd multiply. You'd have to take this decimal part, multiply by 60. It would be 19 degrees and whatever. I'm not going to make you do that, but when you look in the back of the book on 25 to 30, if you try to check them, they're going to do in the back degrees and minutes. I'm not going to make you do degrees and minutes. But if you look degrees and minutes, you'll see those. 31, they want you to do the sine of pi over 3. They say to do the exact value, So you are not going to punch buttons on your calculators and do stuff and round it, because the word exact means you are not pushing buttons on your calculator and rounding things. Anybody have a thought on how you could do the sine of pi over 3?
Replace pi with 180.
Replace the pi with 180. 180 divided by 3 is 60. So we're going to work the same trade we did over here a second ago. On number 15, pi over 3 made 60. In this problem, pi over 3 is still 60. How can you do the sine of 60?
Remember the chart.
Look at your chart. The chart is still alive and well, and here it is coming back on page 39. Every problem from 31 to the end is going to have to make you use the chart. What is sine of 30 on the chart?
Of 30?
Sine of 60, sorry. Sine of 60 on our chart.
Is it root 3 over 2?
Doesn't sound confident.
Root 2 over 2.
Is it root 3 over 2?
What was the lowest we always started with angle-wise?
Zero.
Okay.
30,
30,
45,
45.
69.
1.
0.
0.
Ah.
Root 2 over 2. Root 3 over 2. 1.
So he was right. But you asked it in the form of a question. You're like, is it root 3 over 2? Yes, it is. We're going to need these two, so let's
Wow.
do them.
Okay, 1. Root 3 over 2.
Root 2 over 2.
1 half. 0.
0.
1. Impossible.
Okay, what's a shortcut we can do to help us understand?
Sine over
Sine.
50.
Sine dividing cosine. So 0 dividing style, stuff dividing itself, stuff dividing 0, those are kind of helpful. How about this one?
Root 3 over 3.
Disagree on that.
Root
Root
3.
3.
Just root 3. Because if we divide these, we're flipping this one, we get a cancellation of
2s.
the 2's, the root 3 would be on the top. Here we'd get the root 3 on the bottom, and that would have to get improved.
Root 3 over 3.
What's the other thing that we just forgot if this were a quiz that would have just killed us for 4 points?
The SATC.
Yeah. What does that tell you?
What you use
What's positive where? Let me make up one more of those, because sometimes people have discomfort on this section. But question about the scheme on what's going to happen here on this zone. So let's go pick any trig word, sine, any of them,
Cosine.
cosine. Let me go and make sure I do one that's not on here. Let me say 5 pi over 6. So what would be our first maneuver?
Replace pi.
Replace the pi. We don't like pi. Pi is equivalent to
180.
180. You could do 5 times 180 and then divide 6, but I think that's hard because 5 times 180 gets kind of big. I would do 180 divided by 6,
30 times
because that's 18 divided by 6, but with a 0 on it. Then times the 5,
150.
that gets me 150. How do we do cosine of 150?
Use the calculator.
$90 plus $60.
Kind of, sort of.
180 minus.
What would you contemplate first to try to do trig stuff with 150?
Find if it was closer to 0 or maybe.
Okay, so we think about where we are in the 0, 90, 180, 270, 360 grand scheme of things. Where does 150 live?
A little bit above the 180.
A little bit above the 180, so we're in the S quadrant. So 150 is like there-ish.
Reference angle of 30.
Reference angle, what's reference angle mean? We're going to
The
the,
degree minus.
Actually, the y-axis, or the x-axis.
going to the x-axis to touch 180, so that's
30.
30 difference. Now we're working. Cosine 30 leads us to
Root 3 over 2.
root 3 over 2, but that answer isn't quite right,
It's negative.
because it's negative, because we're cosine, and we trespassed into sine's quadrant, and it's negative root 3 over 2. Well, who is cosines flipping from?
Cosecant.
Disagree. Secant. So if I had done a secant question instead, it would have repeated this whole process, but this answer would be
Flip.
flip. And you're not allowed to have a
Root on the
root of the
bottom.
bottom, so that'll take some more work. Question about the concept, you're gonna, I did just 2 of them now, I'll do a third one if you want. If you look from 31 to 46, you're gonna have to 1, 6, 7, 8, 9, 10, 11, 12. You're gonna have to do it like 30 times. There's a lot of those. Want me to do more, or you got the scheme of what that's about?
There would be none that like wouldn't be on the chart after doing reference angle, for example.
No, they'll all be on the chart. Here's the thing that could help us is, let's turn these all into radians. It wouldn't hurt you to have a radian like memory style thing either. So we did, we've seen 60 was pi over 3. Can anybody do any of the other ones?
30 is pi over 6.
30 is pi over 6.
Forty-five is half pi over 2, kind of.
Yeah, but we can improve that.
Pi over 2. Pi over 4.
Pi over 4 is 45.
And then pi over 2 for 90.
Okay, and we skipped the by far easiest one.
0.
0 is
0.
0. Here's an alternative plan. Okay, there's 2 ways you can do these radian ones. One is turn radians into degrees and do what you've done before. And that's what most people are more comfortable doing. Take a step to the left to my wide open spaces. Instead of 0, 90, do this. 180, do that. 270, you could do this. 360, we could do that. This is still a thing. The one that I just did was 5/6 pi, right? So if this is the full pi line, where would 5/6 of a pi be? Less or more? Less. We'd be here. That's 5 pi over 6. What did we just do to the numbers in those positions over there to get to 30?
Reference angle.
Yeah, what did we do to the math though with them?
Subtract.
Subtract it. If I want to subtract these, I can do it. I need to make a
Fraction.
fractions when we subtraction, we need a
Common bottom.
common denominator. This presently has a 1. We need it to become a 6, so the top needs to become a 6. Subtract those, it's
1 over 6.
Pi over 6.
pi over 6. And if we do the new and improved chart, the pi over 6 new and improved chart could also lead you to root 3 over 2. You don't have to change these to degrees if you're willing to subtract pi fractions. Sometimes people aren't willing to do that. Okay. But if you're willing to subtract pi fractions, did we really need to make it to 150? Not really. Do we need to have the 30? Not really. But we do need to figure out what quadrant we're in, and we do need to subtract something. So if I said something like 11 pi over 6, is that close to 1 pi? No, what's that close to?
2 pi.
That's close to 2 pi, because 12 over 6 would be 2 pi. So if I went over 11 pi over 6 would be over here close to the 2 pi line. If I subtracted that,
Pi over 6.
it would be another pi over 6, and that would get me the same thing that I just did. If you can do the pi fractions, your life might be simpler to just do the pi fractions. If you don't like the pi fractions, act like I never had this conversation over here. You can always replace pi with
180.
180, at which time you're now back in chapter 1 again. You're no longer in chapter 2 or whatever chapter we're in. 180 divided 6 is 30. 30 times 11 is 330. 330 to subtract 360 to make 30. You'd be using the chart with 30 stuff. But if you're comfortable with the pies, just live with the pies. If you're not comfortable with the pies, ditch pi for 180 and live in chapter 1. It's all good. Doesn't matter to me. Tomorrow or Monday will be basically an instant replay of this same lesson, pretty close to it. So if you can master today, you're good for Monday. If you get this homework done and you feel great about it, go ahead and do the Monday homework. Page 39 is going 1 to 46. Page 41, it's almost a replay, at least from 1 to a while. There's a few new ones at the end. We're going to do a little bit of calculator usage on Monday. It's the only thing that's really new. It'll be back to that semi-frustrating day for most people usually where you know which buttons you're supposed to push, but if you push them in the wrong order, you get the wrong answer. Like, are we flipping this first? Are we flipping this last? Are we hitting the second button? Are we not hitting the second button? Like, that's going to come back tomorrow with some button pushing. Anything 39-ish from you? Yeah?
Should we turn our calculators to radian if we're doing?
No, because it won't matter today.
Okay.
Like, you're not going to use your calculators until Monday to push sine or cosine in a radian setting. And if you change them to radians now, it'll mess up all your physics homework when you do the physics homework. Because the physics homework is going to run programs and do some tricky stuff.
All right.
That's it.